Now that we have adjusted the simulation settings, we can jump right into the analysis. There are two modes of analysis, 2D and 3D. Leave it at 2D at the moment. In the 2D analysis, it allows us to visualize the wind flow on a 2D work plane, either a top or a side view. Select the top view option. To adjust the height of the analysis plane, drag the ball at the corner of your wind tunnel until it intersects with your pavilion. Go to a side view using your 3D cube on the top right corner to easily adjust the plane. And that's why an orthographic view is good for that. You can visualize the airflow around and inside your model, either by flow lines or a plane. The different color represents the different wind speeds, and you can see that from the top left corner where the legend shows the speed and the colors. If you select the flow line visualization option, you can adjust the shape of the lines you want to see, and you can adjust flow lines. You can adjust the flow line settings such as line count, speed, size, and length. For the plane visualization option, you can select shaded plane or vectors. The vector option will tell you how the wind will enter your pavilion and at what speeds depending on the color of the arrow. So the light blue colors are speeds that are higher than 10 meters per second, which is higher than the acceptable range for occupants using this space. So we need to adjust our model shape and add some barriers, for example, to ensure that we're blocking the high speed winds. Now that you know how to read the wind speeds around and inside your model, take an image if you're using the plane visualization option, for example, or if you want to have a cooler effect, you can take a video for the flow line visualization. After that, adjust the model's orientation to a new wind direction and change the wind speed from the wind tunnel settings and repeat the process again to make sure that the wind from the incoming directions are not negatively affecting your pavilion. If you want to visualize this 3D wind flow, you can change that from 2D to 3D, but be careful with the simulation time because this will dramatically increase. And the results displayed will be more difficult to visualize and analyze. Another thing you can do is to check the wind flow with the pavilion with no trees, for example. So you can export your Revit model with just your pavilion and test the wind flow if the trees are not there. And this is a way to increase the resolution of the simulation, but without really increasing the computational power. So you can focus on the inside of the pavilion, for example, not just the outside. So after you analyze and decide whether your model needs extra protection from the wind or openings for more natural ventilation, import your updated models and repeat the process again to check the new results. So export those results at the end to have a before and after comparison. This is an important part in presenting how you respond to the wind issues in your model. So that was the end of our exercise for this week. So if you have any questions, feel free to drop in the Q&A sessions, slots that we'll be announcing on Blackboard for this week. Next week, we'll learn how to adjust your designs in response to the sun and daylight. Until next week, stay safe.